Okay. So, um, I guess you have already read no the reading material na gisend ko yesterday. And then chapter 3 no, I will just discuss this in a bit because this is not actually the focus of our discussion this morning. Kay I believe that this can be read naman, no? You can actually just read this because these are just introduction to some terminologies and some concepts na utilize in doing Bayesian analysis. No? So we have different measures to tackle. Pero basically, ang ginagawa lang niya, it's on the concept. And then, of course, some definitions needed kasi there are jargons along the way and there's a need for us to understand those terms in order to connect everything. Okay. So, uncertainty. Uncertainty is a topic that permeates all scientific inquiry and its importance is magnified when the results are applied in decision making. So, di ba, we usually encounter uncertainty. That's why we have to um, kanang ginagawa natin sa probability theory class, di ba? So, but in this lesson, makaka-learn tayo ng dalawang terminologies class and in fact, no, while I'm studying the first time, so first time po na ako siyang na-encounter actually because this was not discussed in undergraduate and some graduate courses. So, okay, despite the general importance of the concept of uncertainty, its meaning lacks a universally agreed on definition, and in fact, it shares its general lack of definition with information as described by late Diba Brata Baso. So, but what is information? So, no other concept and statistics is more elusive in its meaning and less amenable to a general agreed um, definition. Now, in order for us to fully understand what is uncertainty, so let's go to kuan. Kanang i-focus na to ang concept sa uncertainty sa modeling. So, for instance, class, no? Where models are used to mathematically represent real life processes, so there are a number of potential sources of uncertainty. So these may include concerns about the input data, uncertainties in the model description. How will the chosen models represent spatial and other variation, and of course, the stochastic nature of physical processes being described. So uncertainty in one part of a model will also propagate to other parts of the model, and if multiple models are implemented, then uncertainty will propagate through this as well. Now take note na, di ba, especially when we are conducting inference, di ba, there are parameters na usually mga unknown. And then ang atong ginabuhat ana is we try to estimate that because we do not actually know that. And what we actually did in inference is that na a certain value, no? Na instead of getting the entire value, so we choose randomly, and then out from that, say random sample, so we are able to generate a conclusion. And that value nga na-compute natin from a random samples, ang tawag natin dyan usually is statistic, is usually used to estimate the parameter. And parameter is usually the computed value from your population. And of course, that's usually a known. But in this lesson, we will learn two terms actually. The first term is, I think that's aleatory, and then the other one is, wait, where is that? Epistemic. Okay? So of course, no, in doing inference, everything is quantitative. And dili man pud pwede na mag-guess lang gid ta. And that's why later on, so in the succeeding sections actually, so we will discuss various measures needed in kanang sa uncertainty. Though we are uncertain, di ba? When we say uncertain, we are not sure because that's unknown. Pero because we belong to science man good, and science of course is systematic, and so there must be a method in quantifying that uncertainty. So we will deal those measures in the succeeding subsections. So, as noted in the introduction, quantitative uncertainty can be dichotomized. So, the term here is dichotomized, but this is analogous to saying na categorize. Pero ano lang, kaya ginamit niya na dichotomize because ang gina-discuss lang or gina-deal niya is only two, no, for this case. So, one is epistemic, no? So this is a known, and that which is unknowable. So this is aleatory and certainty. Now, what is the difference between unknown and unknowable? So any wild guess from the class, Nolly? So how do you distinguish unknown from unknowable? Just remember na pag sinabi natin na unknown, so we are referring to epistemic, and pag sinabi naman natin na unknowable, so we're talking about aleatory uncertainty. So, and I guess this is the first time you encountered um, these terminologies, no, in dealing uncertainties. So, Noli, how do you distinguish unknown from unknowable? Aside from what is stated in the next line, so you just give me the intuitive meaning, or what's your understanding of unknown versus unknowable. And then you try to you practice kana bitong kuan kas kanang learn to express your kanang ideas jud ini kuan. Sige. So the first refers to a lack of, by the way, am I audible? Madungog ra ba ko ninyo? Saba man kanina gud. Madungog ra ko ninyo? Sige. Let's try to understand, no, unknown and unknowable in this context. The first refers to a lack of knowledge about the processes which generate estimates of the parameters of, teka lang. The first refers to a lack of knowledge about the processes which generate estimates of the parameters of interest, and while the second refers to intrinsic uncertainty associated with the estimates. So, how do we, what's our understanding, no, on that explanation between unknown and unknowable? Ang first ko, no, class refers to a lack of knowledge about the processes which generate estimates of the parameters of interest. Well, ang isa naman is intrinsic uncertainty. Are you familiar with the word intrinsic? Di ba when we say intrinsic, it is innate. No? So, lack of knowledge. So, you do not actually know, but kanang usually ginabuhat good na to again, no? In inference. That's why later on, so mo bitaw to, if you still remember in our previous lesson katong sa chapter 2, so di ba usually ang ginabuhat nato in innovation paradigm is kanang we just assign a distribution and we try to fit or we try to predict the data. So parang ano sila, not the traditional way na ginabuhat nato sa classical gyud, murag another method and another technique. So muna na we learn no from the basics gyud na usually ang ginabuhat nato is we try to assign a distribution to a certain parameter. Kay we believe na kanang the distribution might or possibly explains the behavior of that parameter. So mo to, and then we learn along the way as well na ang iyang ginabuhat is gi-adjust niya ang mga parameter class, the scale, no? Katong kay duha ra man to ka parameters ang ginadil dito. Katong sa mean o sa variance niya class ang iyang scale parameters. So as we notice, if i-adjust na to siya eventually ning fit siya. So though the distinction between the two may sometimes be blurred, kaya nga kanina, tinatanong ko kayo, so parang you as well, no, you are confused. Kasi there is a kanang murag a thin line in between and muna siya magdepende yun na siya class on how do we apply that one, no? Parang context based. But our overall aim is of course the same. And that is to reduce the uncertainty associated with the underlying processes and information required in order to perform estimation and prediction. So, di ba when we predict something, so of course kung mag-predict ka, dili man pwedeng kuan like kanang makabalo jud ka sa outcome. So, or possibly kabalo ka sa outcome pero dili nimo matag-an kanus siya mo occur, di ba? So, isa na siya actually sa mga characteristics sa statistical experiment, no? So, so muna, we learned that one in probability theory na before we are able to um, generate the sample space, so kailangan mo nang gawin natin is we have to perform or we have to conduct the statistical experiment. And how do we conduct that statistical experiment? So naaman tayong mga properties or mga characteristics na kinahanglan i-satisfy before siya matawag na statistical experiment. So actually one characteristic ana is katong um, dapat kanang si tawag ani kung mahimo is independent siya. And then ang atong outcomes should be conceivable, but we cannot predict that one with certainty. Meaning you are uncertain. So, for example, when you toss a coin, so kabalo ka nga ang outcome is head and tail. But you cannot really say nga in this particular toss, so the outcome would be exactly tail. Kabalo lang ta nga head or tail, but we do not exactly know nga tail ang mugawas in that particular toss. You get me? So, isa na siya sa mga characteristics class. And sometimes manggod, it's really a problem if we are uncertain at all times. That's why what we actually do is we try to assign measures. And muna siya class, we will learn that one in this topic. Okay. Now, our main goal is very easy. That is to reduce that uncertainty. Of course, you cannot afford to be uncertain at all times. Now, how can you predict with accuracy if you are uncertain at all times? So our goal is to minimize that one. No, because we will be estimating in the future, we will be predicting. Okay? Now, for example, kanang nganong ma-predict man nato class nga diri maglandfall ang bagyo or ani is kanang aning mga orasa is moagi diri ang bagyo. So just imagine if you are uncertain at all times and then you are trying to predict now what will happen. So of course there will be a panic and then false alarm lang di ito. So we do not want that, and as much as possible we want to reduce that. So how can we do that? Daghana diri class, okay? So we have different methods of assessing that uncertainty. So now to clear things up, so just consider this definition. Class example, sorry, not definition, but example on aleatory and epistemic uncertainty. So this is the best way to distinguish these two terms because I really believe na this is new to you as well. So, as a simple example, let A, so this A class is the event, no? Um, that shaking, so usually we use the term toss, but in this text, we use shaking. So, iuyog niya, a die results in a 6 showing. As we know, a die is 6 faced. And then in this example, um, maybe, no, we are interested on getting 6. So whether or not that event, no, that event of getting 6 will occur is obviously uncertain, may or may not. If it were known that the die is perfectly balanced, so sometimes manggod, di ba? And we learn this as well, manang kung mag-toss ta og coin class, usually ang kasagara ginagamit magid nato sa probability theory, no, when we perform statistical experiment is kining kuan, kining tossing a coin or tossing a die. So mo ni sila ang murag basic gyud. Pero kung mabantayan nato class na when we toss a coin along the way ana or kanang iyahang murag isig kakilid bitaw say anak man is mura nagmo hilis. So kasi dili na mabalanse ang coin. Labi na kanang mga sugaroy sa hantakan. So mo na ang mahitabo ana. So sometimes ma-unbalance ang iyahang side. So of course dili na equal ang probability na makuha. Okay. So if it were known that the die is perfectly balanced, meaning dili siya bias, no? Then the uncertainty in this case could be characterized by saying that there is one chance in 6 of its being correct. So Moto class, what I'm trying to say is the probability is equally likely. So that's 1 all over 6 if the if the die is what is balanced. So if it were known. So if kabalo ka nga unbiased ang imuhang die or equal ang iyahang kuan. So sorry. Class madungog pa ko ninyo. Saba gyud kay sa tanan kay naa man gyud nag-ayo sa babaw god. Madungog ra ko ninyo.
Yes, sir.
Clear man ka. Naa man gyud nagkuan god, nag-repair sa babaw ba. Hindi pud na ako pwede makuan class kay nag-repair. Okay. Sige. So mo ni class na if kabalo ka nga perfectly balanced siya, so kabalo ka nga equally likely, so ang probability niya would be 1 over 6. Pero class, if ang nahitabo ani kung wala ka kahibalo nga unbalance siya and then gi-assume nimo nga likely ang probability, so there must be a problem. Sabta ninyo na ana, no? So could be characterized by saying there is one chance in 6 of its being correct. This uncertainty can never be reduced even if a long string of repeated tosses is observed. So the uncertainty can never be reduced. However, if it were not known if the die is balanced, wala ka kahibalo nga die is balanced and that the likelihood of a 6 in this case is theta. So you cannot really exactly assign a value because wala makakahibalo, no? So, to make things clear lang class, so what you're trying to say here is imo siyang gi-generalize for that matter. So, instead of assigning an exact value, si 1 over 6, kay wala makakahibalo nga nga balance di ay ang die, so para dili lang pud kaayo makuan, so sige, let's assign that as theta. So parang arbitrary lang siya. Okay? One might say the chances of correctly predicting that occurs or katong event class is getting 6, no, is theta. Example of epistemic uncertainty. Matawag na dayon can be eliminated being repeated process. So in the following days, expect na I will be sending lots of reading materials for you. Kay not necessary man good nga I will do all the discussion class. So as a graduate student, you have to practice independent reading as well. So you have to read a lot. So katong gi ano nako class, katong gi send nako sa inyo ha. So you just read that kay it is readable and it is very self-explanatory. So okay. Now let's go to this subsections on data uncertainty. Uncertainty will arise when attempting to obtain information about empirical quantities. Of course, this is very self-explanatory, which have some true value that could, in principle at least, be measured. Diba, mo man usually ang atong, mumangin ni usually ang atong ginabuhat sa quantity class, no? In doing inference. And as we know, class, ang Bayesian analysis is another way of doing, no, of doing inference. So, ang Bayesian analysis is kanang na-discuss siya gamay sa kaselaan, katong sa kaselaan Berger nga text class. So, but very ano lang yun, very brief. But in this course, we will devote the entire ano using Bayesian. But our data is involving space and time. Uncertainty arises when these quantities are inaccurately measured. Okay. So for example, data may be missing or incomplete. So dili na to ni malikaya, no? There are data gyud na kuan na missing. That's why ang atong pinakamadali na mabuhat is to imputate, no? Pero sometimes man good, when we imputate po, dili lang po ta basta-basta o imputate na lang. Siguro okay ra pag ang missing data is ginagmay. What if dinaghana kayo ang missing data? So kinahanglan pud ta og methods in doing that, no? So these missing values may be ignored completely, inducing uncertainty as data are not available. Pero sometimes man good, it's not really good to i-ignore lang pod. So mo na ang ginabuhat is ginapangitaan po na pamaagi nga ma-fill in nato to mga missing observations. Alternatively, values of the missing data may be imputed, for example, by using an average of existing values. By the way, unsa ginabuhat ninyo when you imputate missing observations? Excuse me. Sorry, inom sa tubig ha. Okay. LJ, give me one example nga. Of course, you encountered ka ng mga missing observations sa imong data kay nalagsara man gid kay na mahitabo gid pud na kompleto gid kaayo. Na for example ba, you are trying to kanang mag-create bitaw kag data class. So you are nakay gusto nga i-investigate and then interesado ka ani. Ano lang imong ginabuhat is nag-merge kag file, but of course you found out na in this certain observation wala siya aning certain variable. So those can be considered as missing observation. So unsa may mga techniques nga na-learn nimo LJ in imputing data? Manzanades.
Hi, sir.
Unsa man ang mga usual technique na ginabuhat nimo when you aside from using average of existing values, because this is very common. So muna usually ang ginabuhat nato, we try to catch the observation. Pero ano ni siya, this is for kanang mga ginagmay lang, pero what if mga dinagko na? So we have another technique or methods in doing that. So may mga famous technique na ginabuhat na ninyo.
Kung pag-average, sir. Hello, sir. Sir?
Aside from doing the average, because I already mentioned that one. So,
Di, um, kanang igrupo, sir. Igrupo.
what do you mean? I-grupo ang,
Like, for example, sir, na kay missing data in a week. Tapos,
and then,
i-group lang na mo na, sir, ang sa, example, 7 days. Kung na missing data in a week na in 7 days, so, parang gi-add lang, sir, ba? Seem
okay,
like,
what
a very simple ata. Ang pasabot na.
yeah, what you're trying to say actually is you are getting the average of the one. So, pero mo na siya LJ no, ang may tabo man good ana good. Mo na akong gustong i-emphasize nga in doing that. Of course dili malikayan nga sometimes ma-loss ang accuracy niya. And then mo na ang uncertainty na dayon will arise. Okay? In doing that, so dapat na atay mga measures no in doing that in order to control that. Okay. Sige. Mo na dayon to sa next line ana na din siya na this will introduce uncertainty because of course you do not exactly know those observations. So and then this will introduce uncertainty due to unknown differences between the true unknown and its imputed value. So there's a discrepancy, obviously. Okay? And nanda yung uncertainty. So we have here subsection on model uncertainty. So the basis of a statistical analysis is the formation of a statistical model. So as we know mga good class, wala magi perfect na model, di ba? Na pag sinabi natin na model, so walay model na perfect actually. Unsa gali na usually or kanang murag cliche nga ginabuhat gali nato gani kanang about sa model gani or nakadungog na mo na class kanang usually cliche nga gina-permit or ginaingon nila about sa modeling. Have you heard that one? Ito? All models are wrong. Sa galito? All models are wrong,
but some are useful.
Okay. All models are wrong, but some are useful. Okay. Mabitaw na no na usually ang ginabuhat man gid nato is ano lang man gid approximation class. And mabitaw na if you notice wala bitaw gid nag-stop like nanay techniques para ani, nanay models para ani. So dili lang yun anak dali nga okay humana na dayon. So wala, so constantly nag-improve. Actually dynamic siya ba. Okay? All models are wrong but some are actually useful. So muna as much as possible class na maka-capture siya eventually sa gusto natong lantawon. Pareha tong in the previous lesson, so kato nag-try ta og fit og density sa observation class. And then ang atong nakita didto nga murag layo kaayo siya kay murag din deviate siya. So mura dayon ta naka-learn na dayon ta didto na we have saturated model and we have the a smaller model which is a subset to that parang universal model or katong sa saturated model, and then we try to compute the deviance, no? So katong deviance nag-compute man ta ato last time. Okay? So inana. However, a model will always be a simplified approximation. Okay? Simplified approximation. Of course, kung when we try to mimic something or when we try to model something, complex magud kaayo. And mabitaw na if you notice na kung mag-conduct ta og research, we try to delimit, no? Or naalam tay mga factors nga gipang consider. Pero kung atong mabantayan, naay ubang mga factors na wala na take into consideration. So mao to nga niingon siya nga all models are wrong. Pero kung mahimo, as much as possible, we will try to minimize that error and we will try to minimize that uncertainty because of course we will be predicting and we will be estimating and we will be predicting in the future. Basically in modeling, we are just approximating and kung mahimo ang pinaka-simplified na gyud, no? So simplified approximation of underlying causal structure. So different choices of the model could include different parameters or structural form. So kato mga factors na posible nimo, you can actually supply that one in a in the form of some, no, of some parameters. As well as statistical choices such as frequentist, no, versus Bayesian methods and choice of Bayesian priors. So itong mga priors na to is ano ni siya mga information beforehand ba nga na learn na nimo na possibly might help, no, in predicting the outcome. So muna ang imong ginapang supply. So there will be many possible choices of model and many methods are available for selecting between candidate models. So we will learn that one in the chapter 6, no, of their lesson. So we are now on chapter 3. In addition to statistically based approaches, the choice will some extent be pragmatic and will be based on availability of data and of course what is computationally feasible. Kay naagid po yung uban class na very intensive ang computation. So, very expensive. All right. So now how do we reduce those uncertainties and how do we quantify that one? So we have different assessment methods. So number one is sensitivity analysis. So sa katong paper na ko class in sa akong master's thesis kay nagatakbo ko atog sensitivity analysis sa ako ang mga parameters nga nag-involve sa akong priors kay again you cannot simply supply ng manggod na kay feel nimo nga mao ni siya, so dili man ta ingon ana, di ba, nga we are just guessing. Of course class, when we try to use that one, dapat grounded ta or dapat natay valid reason why we have to use that one. So in this case class, no, kung gusto na ma-reduce ang uncertainty, no, when we model, dapat we have to perform a sensitivity analysis. So there's a need for us to check whether our priors bagyod is really apt, no, or is it really suitable. Kay again, we cannot simply rely on our understanding kay sometimes magud class kini manggong tao is subjective lang. Pero mo na, how can we quantify that one? So we have to conduct sensitivity analysis. So in the book, sinabi niya dito na sensitivity analysis aims to assess how changes in the model inputs, no, either one at a time or in a combination, can affect outputs from a model. So very simple illustration class kanang ginabuhat nato sa regression analysis because regression analysis class is the basic of statistical modeling. di ba kung nabantayan ninyo nga naaman tayo ginatawag og saturated model, di ba? Kapag sinabi natin na saturated model class, so we have to include everything, no? For example, we are trying to predict your grade in this course. So, naamay mga kuan, naamay mga factors sa financial. So, pero we will consider lang sa katong sa mga quantitative lang sa. So, we will not talk about mga Latin for the meantime. So, and then kung imo na siyang i-put in one equation class. So, 'di ba, all those variables can actually affect, no? Or kung imo to siyang i-manipulate, so say for example, ang age ba kaya nimo? So, siguro, ang age has something to do with the memory retention. Kaya as we grow older, we know nga, murag usahay no, mahina na po ang ato ang kuan sa memory. So, posible kaya, and then, if ato na pong dungagan class, if sa imuhang kuan, sakto ba kaya kag allowance? Sakto kag allowance sa DOST? And then, sa kumang yun, um, mga class any variables, no? Any variables na you think correlated sa gusto nimo nga outcome. That's just what I'm trying to say. Nga as long as you think nga naa siya relationship dito. Diba? And we know we know that nga dili man punta pwede pod na i-consider lang nato si diretso as independent variable. So we have to check muna no using the scatter plot diagram if naa ba gyud sila kuan, if nabagyod sila or association, or we have to make use of the chi-square test to test whether they are independent or not. So we know that one, and then if ato na siyang i-manipulate nato na siya class, makita nato nga naay changes, and usually ang makita nato sa changes ana niya class dito sa R squared niya. So naay effect class if dungagan nimo ang variable, na po'y effect if tanggalan nimo og input variable or mga independent variable. Diri class, we're talking about parameters. So the model is run a number of times with different input values in order to observe the resulting change in the output. So of course, independent variable man siya class, no? Or input man siya. So naagid na siya effect sa imong output. So it allows parameters that have large effects to be identified. So possible procedures for such sensitivity analysis include the following. Parameters varied one at a time. Imuhang unsa man nang isa-isahon lang sa nimo. So dili nimo siya dunganon tanan. One at a time lang. So mo man ginabuhat nato sa simulation, di ba? When we try to simulate is we try to change the value, no? Sometimes ang atong ginabuhat, for example, ibutan ta lang og sa okay, very simple kanang sa normal distribution class, how many parameters in the normal distribution man? Shera, Sorongon, how many parameters in the kuan, in the normal distribution? Okay, dalawa. Diba, we know nga kung ato ng usbon-usbon na mga parameters, diba, mag-change man pod ang behavior sa imong distribution. Am I right? Am I right? Or there are other distribution naman class nga special case siya. Diba? Can you give me one instance class nga, or katong murag pinaka-generic na distribution, and then kung natay input na certain value class, na dayon matawag na dayon tayo makagawas or maka-generate na dayon taog another distribution. Unsa to nga distribution class? And I know nga fresh pa kay ni sa inyo ha, because gikan pa man mo nagkompre, di ba? So unsa man to nga distribution? Ito to. Class. Unsa to nga mga distribution class? Or katong sa relationship among probability distribution, i-change lang nimo gamay ang usa ka parameter, mo result siya og another distribution. So in other words, special case siya ana ang distribution. Please give me one example of that.
For example, sir, katong answer like exponential distribution, sir. So special
then?
case just, sir, sa ano, gamma distribution when the alpha is equal to 1. Gamma
When the
has
alpha is
two,
equal to 1.
yes, sir, because gamma has ano, two parameters, alpha and beta. Then if
Unsa to LJ, balik.
gamma has two parameters,
Gamma, two parameters, alpha and beta. Okay, and
then if the alpha is equal to 1, it results in exponential distribution.
okay. Unsa pa gyud? So, okay, thank you LJ. You see class, ingon ana ka sensitive ang atong ko ano, muna nga dili lang punta pwede ka pataka og supply lang na okay mo ni siya ni nana. Pero how do we actually get that one? So if we conduct a so muna nga mag-simulate ka para malanta na to ang behavior niya along the way. Nana. Low sensitivity analysis sees how changes in one parameter affect the result. So di ba na lang siya gamma, gilisdan lang niya ang usa ka kuan class, so the resulta og ang imong hilabtan. Of course, naapod na siya epekto. Okay? So ingana. Now parameters varied in combinations. Global sensitivity analysis where several parameters are varied together. So what if dili na nato usa-usahon? What if dungano nato sila tanan? Okay? So naapod na siya epekto class. Another is extreme values. So all parameters are set at their maximum or minimum values. So what if ato ang i-default ang iyahang value? So naapod na siya epekto class. Okay. Mubitaw na sometimes ang kanang magparan bitaw mo sa inyong R. So or kanang magparan mo sa inyong kuan. So i-check na ninyo kay naa na mga default values dira, and then you try to change the value and then observe what will happen. So that's the best way to learn. So the identification of variables that may have a substantial effect on model output is an important step in any analysis of uncertainty, as it is these variables which are liable to contribute most of the final uncertainty. Just imagine na kini mga parameters na ginasupply nimo are actually informations. So, yun na siya class. Prior informations. Okay? So, muna natin ginatawag og prior, na po tayo ginatawag og posterior. Prior is, ano siya class? It is, again, kanang sabotable na term, prior meaning before. So, imo na siyang gi-identify first. Pero mauna, dapat sensitive po ka in identifying these priors. So, muna nga natay ginatawag og sensitivity analysis. Okay, Taylor expansion is included here. Okay. Pero this is not the Taylor series expansion na katong ginagawa natin yun usually sa in calculus. Pero ano lang siya class. Particular concept na ginagamit lang na gi-apply sa modeling. Di ba kabantay mo katong ni Agi katong asa ganito? I think katong sa estimation man ata sa chi-square no, katong remember mo sa katong previous lesson nga di ba ang pag-expand niya class katong sa estimation is gigamitan man niya og Taylor series expansion. Na-remember mo ato in the last week? You remember that? Katong gagamit siya og Taylor series expansion class. Naka-remember mo to? Hello? I think nawala ka dyan akong connection class. Dili na ko choppy. Lag yapon kayo. Lag yapon kayo.
Dili pa ron sir pero usahay sir kay pag magsulti ka sir kay magputol-putol manggod.
Putol-putol, nawala akong connection class.
Pero naana ka ron sir.
Wait lang ha. Shera, can you pause the recording for a while? If it's okay. I have to fix